All right, guys, here we go. We've actually already done this question. Let's see. Ms. Kyle, do you want to read this one?
Oh, sure.
Yay.
Calculated design sinusoids using the family of functions y equals cx square root 4 minus x squared, where c is a positive constant. The figure above shows the region of the first quadrant bounded by the x-axis and the graph of y equals cx square root 4 minus x squared for sub c. Each spinning toy is in the shape of the solid generated when such region is revolved around the axis. Both x and y are measured in inches. Find the area of the region in the first quadrant bounded by the x-axis and the graph of y equals cx squared root 4 minus x from c equals 6.
Oh, thank you for reading part A. You didn't have to read that part.
Okay.
But I see the toy that they're talking about. Have you guys seen them before? Like, there's like usually like a little something here, and there's like a whole bunch of stuff that you spin, and then you spin it, and it's just spinning. That's what they're talking about. Yeah. So here we go, guys. In the find the area of the region in the first quadrant bounded by the x-axis. Okay, so they're talking about this. Find this area just right now. So they're trying to test to see if you know how to find that. So we're gonna go integral. From what to what. So they don't tell you from where it is, but notice the inside expression, 4 minus x squared. If I equal this to 0, because, why are you equaling it to 0? The y value is 0 there, and the y value is 0 here. You guys notice that? So the domain is from 0 to 2, because 2 squared is 4, 4 minus 4 is 0, square root of 0 is 0. So I'm going to start at 0, and I'm going to end at 2. Does that make sense, guys? And then they already told me what c is. C is 6. So you're going to write 6x square root of 4 minus x squared with a dx. Are we still okay? What's going on, miss? Are you going to return it? Yeah, just put it right there in that disk. All right, so yes. They want me to find this area right here. Do you see that? So I know that the y value at that location is 0, and the y value at this location is 0. The y value on the x-axis is always 0, right? So all I did was I set this expression equal to 0, and I've looked at the inside expression, and the only way that I'll get a 0 if x is 0. Well, because I see the x over here. Well, I mean, I guess I don't need the equation for that one. But for this one, if x is 2, 2 squared is 4, 4 minus 4 is 0, and that'll give me a y value of 0. Does that make sense? Yeah, ask, guys, because I can't read minds. If you guys don't ask me, thank you for asking, Ms. Kyle. If you guys don't ask me, I'm just going to assume that we know. All right, we get to here. And because this is no calculator, they want to see if you know how to do this. They want to see if you know how to do the antiderivative. So you're looking at it and you're like, I can't take the antiderivative the way it looks right now, but I do see a relationship. I mean, maybe if you see the relationship, you don't have to do u sub. But do you see how I have a quadratic on the inside and I have a linear on the outside? When I say inside the square root. So that means if I set u equal to 4 minus x squared, then my du is going to be a negative 2x dx. Do we see that? So I can turn that 6 into a 2. And okay, whatever I have in blue is what I'm inserting in there. So I put the 3 outside because 3 times 2 is 6, right? Okay, what do I need? A negative. If I put a negative on the inside of that integrand, then I got to put a negative on the outside. Are we okay? Okay, so here it is. Negative 3 integral. Notice I'm going to put new limits in a little bit. And then the negative 2x dx is du. So put the du at the end because that's the end of that integral. And I'm going to write square root of u du. Are we still all right? All right. When x is 0, I plug in that 0 in here. When x is 0, u is 4. And when x is 2, u is 0. So this is begging. You don't have to do this, but this is begging for me to switch my limits so I can turn that negative into a positive. 3 integral from 0 to 4 of square root of u du. Do you have to go back to the x? No, do not go back to the x. This is the equivalent expression as the one in the top. So here we go. This right here that I'm circling, that's just u to the half. You can leave it like that, or you can turn it to e to the half. 3, that 3 is this 3. Leave it some space. I'm going to add 1 to that exponent. U to the 3/2 divided by 3/2, which is the same thing as multiplying by 2/3. You put a line, that means evaluated from lower limit 0, upper limit 4. Are we still okay? These 3's cancel out. If you want, you can leave the 2 on both terms, upper minus lower, but I would just factor it out. Make life easy for yourself. Here's my 2, bracket 4 to the 3 halves minus 0 to the 3 halves. You don't need to put the 0 to the 3 halves. You can, if you're scared, you can actually leave it alone. I think we should continue, but that's just me. 2 times, let's see, I would do, you can actually do whichever one you want first, but I'm going to do the 2 first. The square root of 4 is, and then 2 to the 3rd power. There it is. And 2 times 8, that's my answer. So you got to know a little bit of algebra, but it's doable. Ask, what's up?
So can you just remind me, like, when do we go back to the x?
When we have no limits, because then it was never about you, you know. But if you have limits, you're not going back to your ex. Also in real life. No, really, you're just asking for trouble. Like, they're an ex for a reason, right? So leave them alone. Once you or her, we don't judge here. Once you break up with someone, guys, like they're in the past, leave them alone, or her, and move on. Go to the next. Like Ariana Grande says, "Thank you, next." Yeah. No, she does. She has a song. Thank you, next. Okay. So, all right. Here we go. Sorry about that. Hey, Ariana Grande, if you want to sponsor one of these calculus videos, I don't know if she'll ever hear this, but if you do and you want to sponsor, all right. It is known that for y equals cx squared or 4 minus x squared, dy dx equals this expression. So they're being nice. They don't have to, but they're telling us what the derivative is, so we don't have to do the chain rule and all that. They did it for us. For a particular spinning toy, the radius of the largest cross-section circular slice is 1.2 inches. What is the value of c for this spinning toy? I remember when we did this, I said that I was going to put that picture in the second page, and I never did. So let's go back to this. So did we understand what we just read? So go back to this image, and I'll read it again just in case. So while you're looking at that image, think about what this says. For a particular spinning toy, the radius of the largest cross-section circular slice is 1.2 inches. So they already know that you're rotating this about the x-axis, and that the biggest radius that I have is 1.2 inches. Remember, you measure the radius from the center to that curve. That location that I put right there, that is my largest radius. Well, what it looks like visually. Largest radius. And it says, what is the value of c for this spinning toy? Well, if this is my largest radius, this means that my derivative went from what to what? This function went from increasing. My derivative went from positive to negative. So that's how I'm going to figure out what this is by using that fact. Does that make sense? So I would probably write something like dy dx must change from positive to negative. You can probably get away with not writing this, comma, hence dy dx must equal 0. You can probably get away with not writing that statement and just writing dy dx equals 0, but I would probably write it anyways. Does this logic make sense? Okay, so what am I going to do? I'm going to write dy dx equals c, parenthesis, 4 minus 2x squared, close it, over square root of 4 minus x squared. And I'm going to put equals 0. Well, the only way to get 0, we don't even care about the denominator. The only way to get 0 is if I have 0 in the numerator divided by whatever number. I don't care about that 2. I'm not even looking at 2. So all I'm going to do is set this expression, 4 minus 2x squared, to 0. Does that make sense? So then I go 4 minus 2x squared equals 0. I'm going to move the 2x squared to the right. 4 equals 2x squared. I'm going to divide both sides by 2. 2 equals x squared. And then to get x by itself, I'm going to take a square root. X must equal the square root of 2. And the positive one is at that. Are we still okay? Okay, I still haven't found the C value that they want me to find. They want me to find the C. Well, this is where max happens. Where max happens. If you want to check, you can. That's the only location where this is going to change from positive to negative. You can see, well, you can, if you were to graph this expression, it's downward, and that's at square root of 2. That's the only, that's the biggest. You guys know what I'm talking about? If you were to plug in 1, you get a positive. Look, 4 minus 2 is positive. If you plug in a number bigger than square root of 2, I don't know, square root of 3, you'll get square root of 3 squared 3, 2 times 3, 6, 4 minus 6, negative. So it does change from positive to negative at this x value. We still okay? Okay, now here's what I'm going to do. Look what I know. For a particular spinning toy, the radius of the largest cross-section circular slice is how many inches? So that means, look, I wrote it here, largest radius, r equals 1.2. Well, the r is this right here. So that means I'm going to set that equation equal to 1.2. That's my y value at the x square root of 2, comma 1.2. That's what y value. That's what the y value is. Do we see that, guys? No? Okay. They told me read this sentence right here for a particular, and then stop at the 1.2.
For a particular spring toy, the radius of the largest cross-sectional circular slice is 1.2 inches.
Okay, here's my circular slice, and this distance. This is my radius from here to here. Well, check out this kind of. Isn't the distance from here to here just a y value? Are you sure it's a y value? Okay, let me answer that real quick, and then we'll okay. This is Charles. Yeah, she's right here. I can see her. Yeah, you can speak with it. That's what I can use. Or do you want me to send her down? Wait. Okay, let me put her on the phone. It's Miss Cash. Okay.
Keep in mind the lights were off and people were taking naps in there.
I'm just confused on how.
Yeah, it's just
Alright,
so
what
if
do you do that?
you like
This is a square root of 2
Yeah, how does that connect? How does the x value to that?
because it's they told me that this was the highest point. How did they tell me it's the highest point? Because they said it's the largest radius. So on this drawing, you see how that's the highest point? So that x value has to be square root of 2. So that's where I found my max from positive to negative. My derivative came from positive to negative. Do you see how everything connects? So how is what?
How is it 1.2 inches? Like, how is that the y value?
Because this is my radius, but this is also the y value from here to here. That's how you measure y value, right? It's distance from the y axis. So that has to be 1.2. No, you're not satisfied. Tell me, what's going on up there?
I'm just trying to figure out how I can think of this.
Well, as soon as they tell you the radius is 1.2, remember, this is axis of rotation right here. So you got to know, well, okay, what are they talking about radius? Well, the radius is distance from here to here. Well, I mean, it's also the distance from here to here, but I'm not looking at that one. I'm looking at this guy. This curve here, that's that cx squared or 4 minus x squared. And if the radius is 1.2, that means the distance from the x-axis to the curve has to be 1.2. Because this is my cross section. That's what A explains. You know what I mean? You see what we're talking about? Or are you just telling me that just so I can continue?
No, I got it.
You got it for sure?
Yes.
Okay, tell me. Tell me why.
Okay, so we set the derivative equal to 0 so that we can see where it changes from positive to negative.
Or what changes from positive to negative?
Where the
Don't say the word it.
Where the
Nope.
derivative changes from positive to negative.
Okay.
Because that's where the original graph has a peak.
Yeah, because that's the biggest radius, right? Because it says largest cross-sectional radius. Okay. So my radius happens right there because that's where the original graph changes from increasing to decreasing, or where the derivative changes from positive to negative. Okay, so that 1.2 radius is the same thing as saying that the y value is 1.2. Okay, are we okay so far? All right, since the y value is 1.2, I come over here and look, that says y there. So I'm going to go 1.2 equals c times the square root of 2, that's where my x value is, square root of 4 minus square root of 2, close it squared. So here comes algebra. This is probably a point. I don't know. I haven't looked at the rubric. I mean, we did look at the rubric 2 weeks ago. I just can't remember it now. Spring break happened and everything. All right, let's see. 1.2 equals square root of 2, c with a square root of 2 on it, times square root of 2 squared is 2. 4 minus 2 is another square root of 2. Remember, this is no calculator. I see a square root of 2 here, and I see another square root of 2. What's square root of 2 times square root of 2? 2. So I have 2c. And then how do I get c by itself? Divide. So what's that? 0.6. Do you see how we did it? Letter C. For another, any questions? For another, hit me. Yeah, I guess side note, whenever you're multiplying inside the square root of x times square root of y, that's square root of xy. So square root of 2 times square root of 2, that's going to be square root of 4, and the square root of 4 is 2. Or you could also think about it like square root of happy face times square root of happy face is going to be happy face. Whatever you think is easiest for you. Maybe you like the middle one, or cool or not cool. Okay. All right. For another spinning toy, the volume is 2 pi cubic inches. There's my volume. What is the value of C for this spinning toy? Ooh, I like that question. All right, here we go. This is a circle. Area of a circle or a disk, technical term is disk, pi r squared. That's what I'm going to integrate. We still okay? The radius is the distance from here to this curve, or from this curve to the x-axis. So I'm going to integrate, let's see, 2 pi equals, that's my volume, that's that. Pi on the outside, integral 0 to 2. The radius squared, my radius is this. This is my radius. So I'm going to put r is modeled by cx square root of 4 minus x squared. R is modeled by that, guys. Usually I just say y equals, but I just wanted you guys to, I guess I'll say this is y, and then I was right. That's r. Are you guys okay with that? Okay. Cx square root 4 minus x squared. That's my r. Put it in parentheses and put a what on it? A square. Is everyone okay with that? Okay, before I do anything, I'm going to square it. Pi integral 0 to 2. When I square this, I'm going to get c squared x squared, parentheses 4 minus x squared. Are we still okay? That c is a number, so don't get it confused when we do the plus c with like, oh, multiply by 2, it's still a constant. This is some specific number, so I went ahead and just put the square on it already. We're still okay? Okay, I'm going to distribute this. I haven't done anything yet. Pi on the outside, integral 0 to 2, 4c squared x squared minus c squared x to the 4th dx. Did I do it right? We're okay? All right, here we go. Ready? Remember, we're going to treat this as a constant. Antiderivative. Pi on the outside, bracket. 4c squared, leave it alone. What's antiderivative of x squared? Antiderivative of x squared, guys. Minus antiderivative of x to the 4th. From 0 to 2. We don't have to worry about the 0. We just got to worry about the 2. Pi. 2 to the 3rd power is 8. 8 times 4. 32c squared over 3. Minus 2 to the 5th power. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32c squared over 5. We're done with calculus. This equals 2 pi. We just have to do algebra now. I'm going to multiply this by 5 over 5. This one by 3 over 3. Are we still okay, guys? Let's see, pi on the outside. 5 times 32, 32, 64, 128, 28, 38, 48, 58, and 960, 160. 160 c squared over 15 minus 32, 64, 74, 84, 94, 95, 96. 96 c squared over 15. All right, pi on the outside, bracket 160 minus 96. 160 minus 100 is 60, so add 3, no, add 4, 64. 64 c squared over 15. I guess that's fine. I was going to say, does that reduce? No? Okay. All right, remember that still equals 2 pi. 2 pi equals 64 pi c squared over 15. The first thing I'm going to delete are the pi's. And I'm going to multiply this by the reciprocal. So times 15 over 64 times 15 over 64. So what I see now is, let's see, 2 goes into 64 32 times. 15 over 32 equals c squared. That reduces. Wait, yeah, it does, right? It's 3. You know what? Leave it alone. How do I get the squared out of there? C equals 15 over 32 with the square root on it. That's it. What's up? Ask me. No, I think we're good. I think that's it. Sorry, we had a lot of distractions on that one. We're good? Okay. One more, and then we'll call it a day. This one's from the 2009 exam. No calculator again. I'll read it this time. Let R be the region in the first quadrant enclosed by the graphs of y equals 2x and y equals x squared. Hopefully you know which one's which. Notice that they didn't give it names, y and y. Y equals 2x. This one is y equals x squared. Find the area of R. They're being nice. We know this is 0, 0, and we know this point is 2, 4. So to find the area of R, I'm going to go R equals integral from 0 all the way to 2. What curve's on top? 2x. What curve's on bottom? Since this is a no calculator, they want to see if you know how to do antiderivative. What's antiderivative of 2x? X squared. 2x squared divided by 2, so it's x squared. What's antiderivative of x squared? X cubed over 3. Lower limit 0, upper limit 2. We just have to worry about the 2 because it's going to 0 out. 2 squared minus 2 to the third power over 3. Yes, you can leave it like that if you wanted to, but I recommend that we just 8 minus 8 thirds. Multiply this one by 3 over 3. Oh man, did I already mess up? Yes, I did. That's a 4. Yeah, I would have lost my point. Hopefully I would have noticed. I think I would have noticed, but we'll see. 4 times 3. So I have 12 over 3 minus 8 over 3, which equals 4 thirds. How do we feel, guys? The region R is the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis, has area. Find the volume. They're just testing to see if you know the concepts. You guys, how do I find it? They're giving you the cross-section. Let's read it again. The region R is the base of a solid. So this is the base of a solid. That's on the ground. For this solid, at each x, the cross-section perpendicular to the x-axis, so when I cut it like this, I have a cross-section of sine pi over 2x. How does the cross-section look? I don't know. It's some weird type of shape. That this is what it models. Find the volume of this solid. So it's coming out of the board, some wave. That's fine. It has a whole bunch of bumps on the top. How do I find the volume of anything? Volume of anything is just the integral of that common cross section. Integral from 0 all the way to 2 of this sine pi over 2x dx. That's my cross section, guys. They're trying to test. They're testing to see if you know your concepts of how to find volume. Are we still okay? All right. Antiderivative of sine. Positive or negative? Negative. Negative cosine of pi over 2x. Now look, chain rule. If I would have done a derivative, I would have multiplied by pi over 2. I don't have a pi over 2 in the front of that sign. So what do I put in the front of the cosine here? 2 over pi, the reciprocal. Chop, I'm going to get a negative answer. No, you're not. Lower limit 0, upper limit 2. I'm going to factor that negative 2 over pi. Negative 2 over pi. You don't have to factor it out, but make life easier for yourself. A little bit of pre-calc. It's baby pre-calc, not extreme. Let's plug in a 2 in there. I guess let's see it first. Cosine, if I plug in a 2, the 2's cancel out, and it's cosine of pi. Minus, if I plug in a 0, that's just cosine of 0. So I'll wait for you guys to catch up. Here we go. Negative 2 over pi. Cosine of pi. Someone gave me energy. Someone gave me yawn energy because I kind of want to yawn. Is anyone... Okay. Cosine of pi, positive or negative 1? Negative 1. Cosine of 0. You gave me the energy. Remember, I told I'm very sensitive and I can pick up on stuff. I'm not even close. I took an energy drink, but I'm feeding off of your energy, and like I kind of right now feel like I want to do another yawn a little bit, ever so. But see, but I knew it without even because I know, miss. I know the vibe. I don't know if it's you that's giving me the energy or someone, but someone's giving me the vibe. All right, here we go. Negative 1 minus 1, that's negative 2. Negative times a negative is a 4 over pi. I think my mom's crazy. Okay, where is this coming from? I know, right? It's all random. My mom one time told me, and she's so funny. I just kept laughing at her. But she goes that in our family, we're Mexican, right? They believe in like brujeria and witch stuff and all that. And mom's like, your great grandma was a witch, and that it's in our blood that you probably. And so I always laugh at her when I think of stuff like this, like, oh, it's that witch in me. Like I'm joking, Mom. If you ever see this YouTube video, I'm not making fun of you. I promise. It's Mexicans with all their little witchcraft and stuff. All right, here we go. Sorry, guys. I got jokes. My mom got jokes. All right. Another solid has the same base R. For this solid, the cross sections perpendicular to the y-axis are square. Okay, so here it is. They're not perpendicular to the x-axis. What are they perpendicular to? What axis is Miss Kyle? To the y-axis. So it looks like this. Looks like this. Perpendicular to the y-axis, not the x-axis. Right, but do not evaluate an integral expression for the volume of this solid. Okay, well, since it's perpendicular to the y-axis, I got to find these curves, but not in terms of y equals, but in terms of x equals. So this was y equals 2x, so we're going to switch that. So y equals 2x, semicolon, divide by 2. So that's going to be x equals y over 2. And then this one was, I already forgot it. What was it? Y equals x squared, semicolon, square root, x equals the square root of y. All right, here we go. Volume equals integral from what to what? 0 to what? 0 to 4, because those are dy's. Good job. And I'm doing this curve minus this curve, and whatever that distance is, I'm doing this in blue right here. Right minus left, because that's the upper minus lower. Whatever that is, I'm going to square it, because area of a square is side square. Does that make sense? Okay, so rightmost minus leftmost, so there it is. So I'm going to write open parenthesis, square root of y minus y over 2. Close it, put a what on it? squared, and then put the differential dy. These are with respect to y. And do they want me to evaluate it? No. Done. How do we feel? All right, we're done, guys. The rest of the period is yours. See if you can work on some flashcards.